Hi all, welcome to this first video on functions. In this video, I'll talk about how do we write custom functions or our own functions in short in C++. So to begin with, so far we have been writing a single function in all our .cpp files, and that single function is nothing but main.cpp, or sorry, main function. And if you see, this is how a typical main function would look like. And let's try to decode, watch what each piece of this information stands in a main function. Let's start with the first int. We know that int is a representation for integer data type. So maybe this int is signifying that something is being returned by this main function. And whenever we say something is returned by a function, we write this return keyword. We use this stuff called return 0 for main or return 1, etc. So this int is a way of telling that whenever the main function is invoked, or whenever we start running our main function, the main function would eventually return something that is of data type integer. So the way we call this int in this instance is it's a return type. What is a function returning? We'll come to that, but whatever you see at the beginning of a function, that's a return type. It's a data type. It's one of the data types that we have in C++. It can be int, it can be float, double, char, string, etc. But for now, as we are decoding the main function, the return type of a main function is an integer or is of integer type. And whenever we have a return value that is either int, float, string, char, double, etc., we complement the function with a return statement, and we generally write a return statement at the end of the function. So both whatever the data type that we are trying to return, or if the function has a valid return type, we have to ensure that we mention the return statement at the end. So this is a way of telling that what will this function return? This function will return something of integer data type. And how do we return that value? By using this return keyword space, whatever the value that you want to return. So this is so far what we have noticed in the main function. Now the second thing, the main function is a representation of function name. So it's the name of the function. And every function that we write in C++, it should have a name. And up next, every function should have something called as parenthesis. And my bad, I just realized that the plural form of parenthesis should have an E. So I'm just correcting it. Yeah. So now every function right after the function name should have parenthesis. And this parenthesis we'll talk about in detail. But as of now, the rules of C++ tells us that we have to use these parentheses right after the main function. And following this, the fourth and the last component of writing a function would be having something called as a function body. Like our for loop, while loop, if statements, do while loop. In all these instances, we have a couple of curly braces, one left brace and one right brace, and all the code that needs to go under a for loop or while loop will reside in those braces. In the similar manner, all the code that we write inside a main function will go inside these braces. And everything that's inside these braces is what we call as a function body. So the four essential aspects of the main function and functions in general are: every function should have a return type, function name, parenthesis, and a function body. So all these four are must whenever we write functions. And we have seen how these four are embedded into our day-to-day main function that we write. Now, we'll talk about sequential execution in C++. In our previous classes, we spoke that C++ is statically typed language, it's a compiled language, and so on. And likewise, in general, when we talk about programming, we talk about sequential execution. Sequential means one line of code after the other. And all the C++ programs, they should have main function. And program execution starts with the main function. When we do ./a.exe, that means operating system is going to run our main function. We started main method. Now, the idea of sequential execution is that the computer will run one line after the other. In this case, it starts with, in this case, the program execution starts with main method. After that, the immediate statement that will be executed would be creating an integer type called section. So this is the computer's memory. And inside the computer's memory, a variable section is created, and then a variable name is created of string type, and then a variable character is created, a variable grade is created of character type. So sequential execution, one statement after the other. Right after that, we have a prompt for input. So prompt is nothing but whatever the message that we display for the user asking for an input, that particular message is called prompt. And remember, we are using prompts in our lab assignment 8A. So just get familiar with this term, prompt. Now, that means when the computer runs this line of code, an output will be given to the screen telling that enter the section, and so on. The user will give the input. Whatever the input the user gives, it gets stored in the variable. Whatever the user gives input for the name, it gets stored for the variable name. And whatever the input that the user gives for a grade, it gets stored for the grade. So this is basically a sequential execution. At the end, we are displaying whatever the input that we received in a nice formatted manner. So this is what this simple program is doing. So this program is to demonstrate that program execution happens in a sequential manner. It starts at main, it goes line after line, line after line. So that's pretty much about sequential program execution. Now, clear these. Yeah. So now, the next piece is that as of now, we are putting all the stuff into the main method or main function. So we are writing lots of stuff inside main. Remember your assignments 3 to 5. All your code is becoming like the number of lines of code is definitely increasing from assignment to assignment. And you're writing all these lines of code inside the main method. So everything is going inside the body of the main method. So like thousands of lines were started to write code. Now, if we try to put all the logic inside the main method, it becomes a bit complex for us to manage. Remember that semicolon that you missed, or remember that variable that you forgot to initialize, and your code grade tells that there's a junk value or garbage value inside that a variable that you're trying to access. So all these issues are because we are writing lots of or more and more number of lines of code inside our main function. So just to avoid that, what we started or what we'll start to do is we'll start writing functions. So the idea of functions is that instead of having all the logic and trying to make our programs complex for managing, we try to break down our main method into several small pieces which are more manageable. So the idea is that we want to make our lives easy by dividing or by splitting the work or splitting the logic that we write inside the main function into several other smaller components. So that's the first takeaway. Don't write everything inside main. Let's try to make our code less complex. Let's divide our code. And there are several advantages as well on why we divide the code. So let's see them. So these are the disadvantages. And by the way, if we write all the logic inside our main method, and if our .cpp file contains a single main method, like for instance, consider this main.cpp. This is the file name. And here we wrote int main, open the function body, lots of lines of code, and then close it. So if I try to write like thousands of lines of code here, and all the work that we are all the logic or all the code that we are writing in main.cpp, if all of it is done through this main function, then we call this function as monolithic. So a monolithic function is nothing but a function, a single function that has all the logic inside a single CPP file. So if a single function contains all the logic that's there inside a CPP file, then that single function is called monolithic function. And we don't want to write monolithic functions because managing monolithic functions would be a tedious task. So we may get some compiler errors, we may do some initialization errors, we may miss some semicolons and stuff. So there are several other reasons as well on why we don't want monolithic functions. Please go through those reasons in these 3-4 slides. And now, what do we do then? What do we want to do if we don't want to do monolithic functions? So the idea is that if we don't want to do monolithic functions, we'll follow something called as divide and conquer strategy. So let me see if I can pull the whiteboard. Okay, so we follow something called as a divide and conquer strategy. The divide and conquer strategy is that instead of writing everything inside my main method, so let me say, we remove this annotation and go back and show the previous function that we had. So let's take this piece of code. This is a monolithic function here. Why? Because this function has the logic to accept all the inputs. This function has the logic to display as well. So whatever this main.cpp file or whatever the file name.cpp, whatever this file name is, but all the code that this file has is present under main function. So this is an example for monolithic function. So what we'll do is we'll try to break this function into smaller chunks. So let's see that activity. So let's say this is our main function. It has a lot of lines of code. So how do we divide it? We divide it by writing something called as functions. So we write a function for print pattern. So this print pattern, let's say, prints this pattern. And then we will write another function called print details. And let's say this print details is doing this part. So while print pattern is handling this part, print details will display the names of section, name, and grade. So this is what the function is doing, let's say, at superficial level. And we'll also write one more function just to talk about different types of functions. We'll talk about one more function. This last function is, let's say, accept input. Okay. And to make things trickier, we'll also write a fourth function. We'll talk about it in the upcoming slides. But for now, I have a monolithic function where all the code is inside the main method. Now what I'll do is I'll start writing functions. I need to write my main function as it is, or if there is no main function, then our compiler doesn't know where to start compiling the code at or where to start running it at. The computer doesn't know as well. So we should have main function. In addition to main function, we will write several other functions. And we'll talk about how to write these functions, what are the essential components of these functions and stuff. And remember, the reason why I'm dividing this main function into tiny other functions is because instead of writing all the code inside a single main method, I want to manage my code better. And to manage my code better, I'm breaking the main function logic and creating several functions which are more manageable. So to make my life easy as a programmer, I'm writing more modular or more manageable code with the help of functions. So let's start writing some functions then. Oh, yeah. So go through the reasons why we hate monolithic functions and all, and go through the divide and coordinate strategy, divide and conquer strategy. So now I'll switch back and forth between a whiteboard and this. So where do I have white? Okay, so let me. Fine. Yeah. So let's see what all we have under the main method, and let's go back and forth between the presentation and this. So the first idea is that uh, let's write a function to accept the input from the user, or let's write a function just to print the banner. So this sort of whatever the pattern that you see, we generally call it banner or something that comes initially whenever you start a game or you see a printed receipt at some restaurant. So whatever we see, we call it banner. For now, let's call it print pattern. So now I want to write a function to print this pattern. And if you see, this is how the function is. The function has the four essential components of a function. The first one is return type. Okay. So in this case, the return type is void. So this is the first time, I think for the first time we are seeing this return type called void. All other valid return types are day-to-day data types that we see: int, float, double, character, and string, and so on. So these are all we are seeing in our day-to-day programming. But now, for the first time, we are seeing something called as void. What void tells a computer is that it tells that this function, print pattern, this is the name of the function, by the way. So this function is not returning anything. So the first thing that we are learning in this slide is whenever a function does not return anything, if a function doesn't return anything, then we say void. Void for return type. So that's the key. If a function doesn't return anything, let's just say that its return type is void. And if a function doesn't return anything, we can skip the return type value or the return statement. So let me do this thing. Annotate here all drawings. So this particular thing void here, it signifies the return type. Return type of this particular function print pattern is void. If the function does not return any value, then we can use this void as the return type. And the role of this particular function is to print this pattern message, some stars, CS135, and some other stars. So void print pattern means it's not returning anything. That's why void. And now the return statement, notice that I'm not using a return statement at the end of the function. So if we are specifying that a function's return type is void, then we can skip writing the return statement. If we write a return statement when the return type is void, then it may throw a compilation error. Just check on that. So we don't need to write the or use the return keyword if the return type of a function is void. Okay, and now this is the name of the function. And remember the four aspects that we spoke about a function: return type, it's void; name of the function, print pattern, like how we give meaningful names to variables. Ensure that you give your function names with a purpose. So this is the function that kind of prints the pattern. So I just gave it a name called print pattern. And Intentionally, I'm not talking about the function parenthesis here, but we'll talk about later. But for now, it's an empty parenthesis. Let's talk about it later. So now let's focus on the function body. What does a function body contain? Function body contains whatever logic that the function is supposed to do. In this case, this function print pattern is supposed to print some stars, some text, and some other stars to the screen. So that's why we just have 3 lines of code inside that. In these 3 lines of code, the couts, everything put together, these 3 lines of code, they form the function body. So function body is nothing but whatever the lines of code that we write inside these curly braces. All the code that goes inside a function's curly braces is what we call as function body. So once again, every function should have a return type. Every function should have a name, and this name should be a meaningful name. And every function should have a parenthesis, we'll talk about later, and the function body. So all these 4 are the essential aspects of writing functions in C++. Now that we just have defined our first function, so this entire thing, let's say we just wrote our first function. Now that we wrote our first function, the question is, where should I keep this function in my main.cpp or in my C++ file? Should I write this function before the main method or before the main function, or should I write it after the main function? So it turns out that you have 2 options. If this is my main method, so just notice that I'm starting with an empty main method for now, not much of content. So if this is my main function for this CPP file, I just placed whatever the function that I wrote above the main method. So it turns out that we can place the function above the main method. This is totally fine. And the next step, if you notice, the only statement that I have in this function is print pattern. So whatever the statement that I have here, this print pattern, this means I'm letting the computer know that, every computer starts its program execution from main. So start at main. And once you start at main, go inside. And when you reach here, remember the sequential pattern? When you reach here, execute the logic or execute the code that's there inside a function. So I have to tell the computer that where it has to execute the function code. So the way I tell a computer that right here, right after going or entering inside a main function, right after entering inside the main function, I'm telling the computer that this is where you have to run, this is where you have to execute whatever the code inside the function is there. And this part is what we call as, or what we term as, calling a function. So whenever I write functions in C++, it is my responsibility to ensure that I write the entire function with the 4 aspects that we spoke about. And then I should also explicitly tell the computer that this is where you have to run the code that we have under a function. Now let's see how this program execution is. Let me show that. Yeah. So yeah, like I said, every program execution begins with main, likewise in this case. And then the next thing is I'm telling the computer that go run whatever that's there inside that function. This approach or this aspect is called calling a function. I'm calling a function in this part. And then now the control of the program goes from main function to the print pattern function. And inside the print pattern function, the computer will run the statements one after the other. It will print some stars to the screen. It will print CS135 and some more stars to end with. And then after executing the function, the control returns back to the main function and then done. So this is our first aspect of a function. So far, this is where we are at. Let me show this. let's say functions one.cpp. So the way we write function is hash include iostream using namespace std and main. This is where I'm writing my main function. And before going inside my main function, I'm starting with something called as void print or just say print pattern. So the return type is void. Therefore, no need to write a return statement. The name of the function is print pattern. And then the function body. What are we writing inside a function body? We are simply printing some stars. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then endl. And then I'm saying that CS 135. And then endl. And I'm writing this function or this line of code again. And now if I run at this point of time, notice that functions, okay, it should be functions one.cpp. And yeah. So if you see, nothing happens when I run this code. The reason nothing happens because I should call the function. So ensure that the function print pattern is called and print pattern. So now if I call that function and compile it and run it, you see a pattern is printed onto the screen. So we just defined a function. This function doesn't return anything, and hence the keyword void. The role of this function is whenever we are calling this function, it simply prints out some pattern to the screen. So print pattern is what this function is about. So for now, I just wrote this function. And notice that I wrote this function above the main method. Now we'll go back to our slides and we'll see how we can write a function after the main method as well. So we can place the entire function after the main method as well. And so this is the main method. Turns out that you can place the same function as it is under the main method. But there's one extra work that we have to do is that we have to tell the compiler that I'm about to write a function. It's just that I have to tell that somewhere below the main or somewhere inside this program file, I'm going to write a function. And that function returns nothing. And the name of the function is print pattern. And it will have parentheses. So this is to indicate that it's a function. So let's see this part. All I'm doing is clear my drawings. So the same function, let's say, I'm taking it below the main method. I'm pasting it here. I'm saving it and I'm trying to run it. If you see, it's a compilation error. The reason why it's a compilation error because program execution starts at main method. Okay. And when the compiler tries to run it, it doesn't find or it doesn't know where to look for the print pattern. So that's why what we do is that we simply tell the compiler that somewhere in this file, I will write a function called print pattern. This function will not return anything. So void print pattern. And then I just let the compiler know that part. And I'm running it. Now it compiles without any error. Oh, my bad. And now it also runs. So no matter where I write the function, I should always ensure that I'm calling that function. If I'm writing the function below the main method, then I should do this extra little step. to let the compiler know that somewhere inside the program, I'm writing a function. And now, the interesting aspect to talk about is that I just have written the function print pattern. So let's see how this function is. Void, this doesn't return anything. And the name of the function is print pattern. And then the function body. Here, I have some bunch of cout statements. Stars. Just for the sake of writing, I'm doing only 5 stars. And then cout CS 135 and L, and then cout, and then the 5 stars, and then NL. Remember, the function doesn't return anything because the return type is void. So this is the function that we wrote. We know that whatever that's between the curly braces, this piece of information is called function body. Okay. If this is what we call as a function body, then this is what we call as a function header. So this piece of information is function header. This piece of information is function body. And the other names that we have for function header are function prototype, function declaration. So all these are synonyms or other names for function header. So when we write a function below the main method, we should tell, or we should write at least the function header. So when we write a function body below the main method, then at least we should write the function header or function prototype before the main function. So this is something like a C++ rule. So back to slides now. We have two options. You can write a function above the main, or you can write a function below the main. If you're writing the function below the main, then at least you should write the function header or function prototype before the main. Then the compiler will not throw an error. So we just have written our first function, print pattern, and we have seen how and where all we can place that first function. So we tried placing it above the main function. We tried it placing below the main function. Both of these work, and ensure no matter where you place your function, ensure that you're calling that function. So the first part of the video, I'll take a pause here. So we just have seen how to write a first function, how the program execution also flows from one part to the other whenever we write functions. I'll stop sharing and I'll record another video for the next topics.